through the 21st century now, and the idea of a multiverse or multiple universes is becoming more and more accepted. It's still a controversial prediction in physics, for sure, but there's also an increasing number of researchers who suggest that a multiverse is logical and sometimes even unavoidable. For example, today's scientists have a pretty good idea that the universe is inflating, and most theories indicate that it should be flat, two conditions which, in themselves, theoretically allow for a multiverse. Meanwhile, year by year, we're getting a better understanding of quantum physics, which can be applied in a variety of ways to further flesh the theory out. For the renowned physicist Max Tegmark, then, we can start to think deeper, to ask not whether there is a multiverse, but to inquire which level of the multiverse we're actually living in. Tegmark's model of the multiverse is perhaps one of the simplest out there on paper. He suggests that there are 4 different levels to the multiverse, each one bigger than the last and expanding on the previous level's foundation. Tegmark's first stage, Level 1, has often been described as the least controversial of all of them. Even so, it's what we'll be focusing on for this video. So, what is a Level 1 multiverse? Firstly, it ties in again with various evidence that points towards our universe being both flat and infinite, with a seemingly even distribution of matter. The crux of Tegmark's first level, then, is that if the universe really is infinite, it should mean that all particle arrangements, no matter how unlikely, will occur again and again, given enough time and distance. This kind of multiverse is still contained, in a manner of speaking, within one structure, and all of it is still bound by the same fundamental rules of physics. It's just that because there's no end to that structure, there's no end to what's possible. And if particles have aligned in this way once already, that is, in the way in which we all appreciate them in our lives, then they can do so again and again and again to infinity. And they can do so in every other possible way, too, forever. At the heart of this model of reality, there's the fact that astronomers are, in a sense, aware of 2 universes, the observable and the unobservable. The notion of the observable universe is closely linked to what's known as the Hubble volume, which refers to the part of the universe that holds everything that we can see. However, because we're also aware that space is expanding faster than the speed of light, we know that there's another unknowable universe out there too, existing beyond what we can see. It's here, according to a Level 1 multiverse, that plays host to a limitless number of particle possibilities, including repeats, potentially endless repeats. While not strictly the same thing, here's where the idea of parallel worlds usually comes in. Because in Tegmark's Level 1, there's a genuine theoretical possibility that there are other versions of you existing on the same plane of reality, just very far away. Tegmark has actually calculated an upper limit for how far from our universe your potential doppelganger could be, suggesting that they could mathematically reside 10 to the power of 10 to the power of 28 or 29 meters away. When said out loud, that doesn't sound so far, but in reality, it's a distance so vast that we may never ever be able to breach it, no matter what technology we were able to develop. But of course, between here and that imagined place that's identical to here, there could or perhaps should also be whole universes with changes made, large or small. In the words of Tegmark himself from a 2005 paper titled The Multiverse Hierarchy, in which he outlines the proposed multiverse levels, quote, "There are infinitely many other regions the size of our observable universe where every possible cosmic history is played out," end quote. Among other things, this means that there is, according to the Level 1 model, an Earth where Germany won World War II, one where World War II never happened, one where Abraham Lincoln was never assassinated, a solar system where humans already live on Mars, and presumably a solar system where Martians already live on Earth. Perhaps the most tantalizing aspect about all of this, though, is that these other worlds and histories don't exist on alternate dimensions or higher planes of reality. They exist in the same general place as we do, and the only thing separating us from them is the many light years of space between us. Nevertheless, the implication is that hypothetically, if we could surpass the speed of light and travel the universe in a cosmic rush, we could theoretically visit all other universes that are just like this one. Here today, then, this version of the multiverse, the Level 1 multiverse, is only unreachable to us because of its vastness. But it also seemingly implies something else faintly mind-blowing, that space has no end or edge to it. That even if we could travel at any speed, millions of times faster than light speed, for example, no one could ever reach an outer edge of the Level 1 multiverse. And yet, just to melt the brain even further, this type of multiverse also implies that every probability can happen. So if there is a non-zero chance of humanity or any other group ever developing a workaround to this problem of infinity, then it will happen eventually. Meaning that someone, somewhere, should be able to achieve the seemingly impossible, and despite us saying that no one should ever be able to do it just a few seconds ago, they will get to the edge of the multiverse. But finally, how could all of this make us feel? Well, another inherent assumption with this particular model is that universes like ours are common. That if you travel far enough, you will find this place we call home again. With Tegmark noting that we can reasonably consider our universe to be typical in terms of its arrangement of matter. So if a level 1 multiverse were proved, it might feasibly lead to a massive sense of listlessness or demotivation among the general public here on Earth. After all, if there really are infinite versions of everyone, then nobody is unique anymore. And therefore, if you were to spend your life lazing around, then that would be fine. Because there's always another one of the endless possible versions of you out there that will become president instead, or cure disease, or travel to their version of the moon. In some way, your success and failure is guaranteed, because it will certainly happen somewhere. It's a massive psychological shift from those early cosmological theories mentioned at the top of this video, wherein humanity at one time placed itself at the center of the universe. In a level 1 multiverse, by comparison, we're not only not the center of anything, we're also but a speck on the infinite scope of reality. But on the other hand, this realization could also be exhilarating. It would tell us that every possible physical and biological formation does exist somewhere in space. That there are planets out there that double up as perfect utopias. Heaven-like worlds populated by always happy life forms. Of course, one person's version of paradise may differ from another's, but with literally endless options out there, all iterations really are covered. As with most multiverse proposals, it can all sound a little sci-fi at times. But again, many scientists argue that the theories, or significant parts of the theories at least, do make sense. Max Tegmark has gone so far as to argue that if you believe in quantum physics, then you should also believe in a multiverse. For now, what we do know for sure is that there's the observable universe, and that there's more universe beyond that. What lies on the other end of the light could very well be an unending supply of other worlds. A level 2 multiverse, according to Max Tegmark, takes the idea further and envisions even more varied possible universes. In a level 1 multiverse, space stretches on infinitely and encompasses everything we know, but it is all at least still contained within the same infinite structure. A level 2 multiverse, however, proposes that our universe, our level 1 multiverse, is actually held in a bubble, and that bubble is surrounded by countless other bubble universes, some of which are again like our own, and some of which are very different. These bubbles are then separated by vast stretches of space-time to form the new and overriding multiverse structure. The gaps between could be so vast, however, that even were you to be traveling at the speed of light, you wouldn't be speedy enough to move between them, since the space-time itself is expanding faster than even that. Moving between or communicating with universes in a level 2 multiverse, then, is theoretically even more difficult than it would be in a level 1. But nevertheless, what happens in these other unreachable bubble universes? Well, according to the theory, some could have totally different physical and fundamental characteristics. This is the main difference between level 2 and level 1. As they're not necessarily guided by the same fundamental laws, these other bubble worlds could have different dimensions, different physical constants, and even different elementary particles from those we see in our own. This creates the potential for some seriously strange universes out there, where, for example, gravity is weaker, so there's no such thing as a home star or star systems, or where atoms are unable to form altogether, and so there are no stars to speak of. For decades, scientists have puzzled over how it is that our universe, right now, appears to have hit a kind of sweet spot with the laws of physics, enabling things to be the way they are and for life to form. This idea isn't always all that popular because it suggests that the universe works due to pure chance and coincidence, which is frustrating at best and faintly terrifying at worst. But here, a level 2 multiverse is seemingly able to provide answers. Broadly speaking, the issue of the universe having perfect values for life is called the fine-tuning problem. Regularly cited examples of it in our world include the masses of elementary particles and the density of dark energy, both of which have to be exact. If they weren't exact, then the chances are that we wouldn't be here to ponder them, because none of this universe would be possible. If our universe were the only universe in existence, the chances of these numbers being so perfect seems frankly impossible. And that's the fine-tuning problem in action. In a level 2 multiverse, however, the problem is solved because our universe is no longer alone. It's simply the one that did work while endless others didn't. Among the infinite bubbles that a level 2 multiverse proposes are, then, an untold number of bubbles that could never support life or form basic elements, which makes it easier to accept that ours, through sheer cosmic repetition, can. On the other side of the coin, it also follows that in a level 2 multiverse, there are also other bubbles that can form everything we know and more. Physically impossible life forms and structures from our point of view, but simple and expected in these other worlds. The possibilities here are essentially endless. There could be alternate bubble universes where the speed of light is significantly faster, allowing for more stars to be visible, but also ones where light doesn't move at all and darkness reigns, and so many others where hydrogen and helium weren't quite so crucial, or in fact never formed. And so the universe grows differently from the outset. Or perhaps carbon isn't so abundant, and so life uses something else. Then again, life forms in another bubble could be living out their lives in 2 dimensions, all while trying to work out the 3rd dimension, whilst the inhabitants of another exist in 7 dimensions all at once, making them naturally able to experience things that we ourselves can barely comprehend, and yet they would think nothing of it. It's predicted that all of these different worlds in a level 2 multiverse exist inside an infinitely expanding pattern of bubbles that's forever unknowable to us. Were we to somehow observe them from afar, then we need a godlike level of power. This level of the multiverse does share similarities with other theories, though, as Tegmark himself has variously pointed out. According to the physicist Lee Smolin, for example, our expanding universe could theoretically create black holes so dense and endless that other universes could potentially form inside of those. Another theory holds that multiple universes could instead form out of an infinite series of big bangs across space. There are, of course, big differences between these ideas, but they're all linked by the suggestion of a multiverse that could hold universes which all have totally different fundamental properties, changing dimensions of time and space, a differing number of elements, or a changing makeup of atoms and matter. One question this might cause scientists to ask then is, which conditions really are ideal for life? So far, we're the only example of life that we can see in our universe, but does that automatically mean that our universe is the best suited? Or could it be that there are other universes out there, in different multiverse bubbles, where life flourishes on every planet and not just one? Is there then a perfect universe in and amongst the countless possibilities? And is that a reassuring thought to us down here, or could it trigger a worldwide, universe-wide, existential crisis? If nothing else, we can see that a level 2 multiverse is massive, both in terms of physical size and in terms of how much its existence could shatter more traditional universe models. According to the famed philosopher Arthur Schopenhauer, truth must go through 3 phases before it's accepted in the mainstream. First, it's ridiculed by others, then it's vehemently challenged, and finally, it's accepted as self-evident truth. The idea of parallel universes isn't quite at the last phase yet, but it's long past the first. This concept is now entering the mainstream in a big way, which means the race is on to truly understand it. Tegmark's Level 3 predominantly rests on the theory of quantum physics, and whenever quantum physics is involved, stuff in general gets weird. The many worlds interpretation of quantum mechanics was first put forward by the physicist Hugh Everett III in the 1950s, and it's this idea that forms the basis of Level 3. In the many worlds interpretation, the universe is dictated by quantum events, and all outcomes have a home. Let's take the simplest action of chance, a coin toss. In a many worlds reality, when someone flips a coin, they're put into a state known as a superposition, which means they exist in more than one state at once. The coin will then land on both heads and tails, and the observer will both be excited and disappointed by the outcome at the same time. A Level 3 multiverse splits at this point, however, creating one true reality where heads landed and another true reality where tails did. Both are equally real. So the theory goes, these realities then exist all around us, but in an abstract realm, rather than in identifiable reality. Surprisingly, a Level 3 multiverse doesn't allow for any new possibilities beyond the somewhat physically restrained Level 1 or the physically free Level 2. Instead, it might be argued that Level 3 is more to do with populating a multiverse, with explaining how so many multiple universes, infinite in fact, come into being. The quantum branching at the heart of this model, the heads and tails superposition, simply creates fresh worlds all the time. But none of those worlds are governed by anything new. They all follow the same physical laws that dictate Tegmark's first two levels. In essence, then, the only major difference in Level 3 is where these other worlds are found. For example, while in Level 1, all worlds are some fixed distance away from us in space, at Level 3, they exist all around us, all the time, but in another realm entirely. There are whole planes of reality that kind of whisper around our lives, but we can't see, feel, or experience them. Time also works a little differently in a Level 3 multiverse, though. The traditional view is that time is what allows change. So whenever a difference is detected in a system, leaves have fallen, flowers have grown, or the tide has gone out, for example, we know that time has taken place. The Level 3 framework sees it differently, though, instead viewing time as the sequencing from one universe to the next. So when you flip a coin and it lands on heads, the shift between two possible universes, from the one with tails to the one with heads, is time. So now, time is little more than the ordering of all the specific possible universes that constitute your life, which is perhaps enough to trigger an existential crisis or two. What's more, it arguably figures that somewhere within a Level 3 multiverse, the existence of a Level 3 multiverse is widely known and not just theorized as it is in this reality. But also, as a result of all the countless decisions and splits within your own life, there's somewhere where it turns out that you are the one to have proven Level 3 to the rest of the world. It might be pitched then that this kind of multiverse operates as though for everyone and everything all the time. It's just that we're only conscious of one infinitely small slice of it at any given moment and during any given lifetime. These aren't the only bizarre considerations that Level 3 inspires, however. For example, there could be implications for immortality. If there really are unlimited versions of you that branch out at every possibility, essentially coexisting in the tight and endless mesh of reality, then there's at least one of you that survives every accident. And depending on whether it's ever physically possible, there's at least one of you that lives forever. Say you're in a car accident where the chances of survival are 50-50. Your life is placed into a state of superposition, out of which comes two possibilities and two universes. One where you live and one where you die. Within the one in which you live, say you were then involved in another car accident the following day. The chances of surviving both events drops to 25%. But still, at least one version of you inevitably does survive. The following day, there's another accident, and your chances drop again. And then another and another. This could continue until your chances of survival are infinitesimal. But still, even were there to be a 0.00001% chance, at least one of you somewhere will survive in a Type 3 multiverse. It's an idea that's tied up with another thought experiment, explored by Max Tegmark and others in the past, known as quantum immortality. In this version of the multiverse, it seems there truly is no end. As such, the idea of existing at Level 3 might feel strange or maybe frightening, but it of course matters little with regard to our day-to-day lives. Scientists are continually searching for the secrets to reality. But until such day as those secrets are revealed, perhaps it's best to simply enjoy and engage with the experience as we live it. A Level 4 multiverse is even more fundamentally based on one of the greatest questions in science. What is reality? For Tegmark, there are two main schools of thought. The Aristotelian paradigm says that physical reality, and what we experience of it as humans, is real, but we use mathematics to try and make sense of it. While the Platonic paradigm takes the opposite stance and sees mathematics as the real truth of the universe, while our perceptions of it are only limited approximations. More broadly speaking, Tegmark shows how this question of reality has important implications for general science. For example, if the Aristotelian view is the right one, then scientists will never find a theory of everything, since our subjective experiences are all different. If the Platonic view is right, however, if mathematics makes up the universe itself, then there is a theory of everything out there somewhere. With regard to Tegmark's multiverse specifically, Level 4 sides with the Platonic view, that mathematics is key. The proposal first draws upon our overriding innate reliance on math in just this universe. Mathematical laws seem fundamental to us. For instance, when humanity launched Voyagers 1 and 2 in the 1970s, we equipped them with a golden record inscribed with various attempts to communicate with potential aliens through science and math. Our cosmic position given pulsar locations, what our hydrogen atoms look like, and various instructions coded in binary. They were all etched into the now far-off golden discs. The thinking being that math should transcend any possible language or communication barrier between us and whoever should find the Voyagers. The thinking also being that the universe is, in essence, made of math. But Tegmark takes the notion further for a Level 4 multiverse, by drawing on ideas such as Robert Nozick's fecundity assumption, which suggests that if a world is possible, then it must exist. Level 4 supposes, then, that all possible mathematical equations, and therefore worlds, must take place somewhere. Even with the infinite bubbles and endless splinters of the multiverse as per levels 1, 2, and 3, there must also exist more than just the mathematical world of this universe or this multiverse to contend with. This creates an essentially infinite degree of versatility and an infinite number of possibilities. Levels 1 to 3 already allow a huge amount of diversity in terms of dimensions and possible elements, yes, but all must still conform to certain natural expectations. Time, motion, thermodynamics, and more must be adhered to. However, this isn't the case at Level 4, as any one multiverse can ultimately have totally different laws of nature compared to any other multiverse. With only the endless possibility of math to guide it, there's really no telling how reality could unfold in any one place. This creates worlds that are very hard to imagine. There could be universes where time moves backwards, or in irregular spurts instead of along a dependable line. There might be places where gravity exerts itself in a wholly different way, or where thermodynamics works differently as well. Universes where motion works differently, for example, could have moving objects that naturally get faster as time moves on instead of slower. Or perhaps there'd be a place where there were only two speeds, 0 and the speed of light, which can now be anything too and not just the speed of light as we understand it. These worlds are of course so difficult to imagine because we're so used to the reality we just so happen to live in, where objects fall to the ground and light travels at a consistent speed. But when those laws can vary, anything is possible. Beyond just what's inside them, however, every universe in a Level 4 multiverse is also a mathematical shape. Thinking about just our universe, that means that somewhere, at some higher level of understanding, even it could be described as a specific shape by mathematicians. But now every other possible shape should also correspond to a universe too. And herein lies the basic endless landscape for a Level 4 multiverse. Every mathematical shape imaginable has an accompanying reality. These aren't optional either. Tegmark suggests that if a shape is mathematically possible, then it must have a real physical incarnation. He calls this principle mathematical democracy, highlighting that the multiverse isn't simply allowed to pick and choose which shapes to represent, and so it must represent all possibilities. There is no cosmic favoritism or asymmetry in a Level 4 multiverse. One final realization out of all of this, however, is that Level 4 would mean once and for all that our universe isn't special. Instead, it's just a mathematical shape in and amongst endless other mathematical shapes. It's just a ball of complicated equations in a never-ending mass of other balls made up of other complicated equations. A Level 4 multiverse is then the last and definitely final level of Tegmark's multiverse model, as it could never be superseded. Because if we were to devise some other structure to contain all possible multiverses to this point, then really we'd have only devised another mathematical shape, another mathematical reality. And so it would simply be a continuation of Level 4. So what might the future hold for us? Will the multiverse ever be officially proven and confirmed? Or will it remain a subject for increasingly confident scientists to debate only? Across his various articles, papers, and presentations, Max Tegmark appears to concede that Level 1 to his model remains the easiest to come to terms with and therefore the least controversial. But as we move up through the levels, his bold attempts to explain reality gets more and more exciting. At the very top of Tegmark's thinking, even whole universes become really quite tiny things. We've moved from one infinite expanse to infinite bubbles containing expanses, to the many worlds of the quantum realm, to the mathematical structures that could encase them all.
It's been quite a journey through all those different degrees of reality, exploring the bleeding edge of theoretical physics.